This is that wiper. Huh? Some small application-based question in viscosity, some application-based question. Okay, let me get into the diagram part. Everything is a glass, only that wiper area is what we are showing it. Okay, there's a rod. Okay, the width of this is, so here this length is L, what we have. Okay, now, so what is the thing? The engine will exert a force. So I'll write torque due to motor. It will wipe it, no? And there's a glass part. Glass is not that one. Everything is a glass. There's a wiper area where the wiper will be in contact with the glass, that one. So how as it is, this will be rotating with an angular velocity. I think angular speed omega, rotating at a constant angular speed omega. Okay, let me take a small element here. What is the speed of this element? Let it be V. Let this element be located at a distance R. How the viscous drag will be acting on it? On this small element. dF. Okay, let's get into first, let's calculate this dF. Okay, the length of this element, let it be dr. I think I can't show. Yeah. Let's write here. So what is dF equal to? Viscous force. This should be equal to dF should be equal to eta dA. Velocity is V. Look at something is telling some thickness T. There is a uniform layer of water of thickness T on the glass surface. So shall I put that T here? Okay, now I think most of you might have seen. Why do wiper water will come? I think the moment you switch on the wipers in the car, no, especially the four-wheeler, water will be sprinkled, then wiper starts rotating. So what is the reason for that? The water layer, the thickness of water layer, that is T. So this is very important. If there is no water, the dry wiper, what happen? There'll be scratches will come. So what is the best way of preserving that glass? I think that is very important. No, that we'll call like a windshield. The front glass is called like a windshield. Before switching on wiper only with a cloth, what happen? Try to remove the dust first. Try to clean at least like a take it off, wipe off the dust. Then what happen? As you before beginning of moving the car, what happen? You have to press in such a way that water will come, then wiper will automatically start rotating that one. First, water will come. Okay, so I think you see the wipers, there'll be rotation, 3 speeds will be there, no? What do you suggest? First speed, second speed, third speed. Some of you might have car and you might have driving this time. What I should do with the wiper? First 2, 3 speeds, adjustable speeds will be there for wiper. Am I right? Some of you might have driven that car. I think the first only you have to put it, no, because in the first only what happens, the wiper will move slowly. If the wiper moves slowly, you look at this viscous drag will be less, the scratches will be less. Suddenly, if you go for higher speed, the wiper, no, then what will happen? At a high speed, what happen? More viscous. So what will happen? That the viscous drag will be more, scratches will be more. So when you are using it, what happen? The first initially should be at lower speed. Gradually, you have to increase speed. I think if you don't have this idea, you ask your parent or any technician, or they'll tell like how to use wipers, or Google it, you'll come to know. Okay, now let's come back to our discussion. Okay, the T is thickness of water layer. Okay, I think we are in better position now. So eta, what is dA there? dA will be dr into B. What is V? V equal to R omega into T. Okay, this will be eta B omega by T. Let me keep this is dF. Then what is the torque by viscous drag? It should be equal to dF into R. I think somehow you should understand the question. It'll be very easier. Where all the viscous drag will be present? Only in this region, no? From what are the limits? Capital R to R plus L. Please try to understand. Only here is what the viscous drag force will be acting. Now, same force will act at all points or different force. I think here this having more speed, no? So if you look at the magnitude of force that is acting on the this wiper, no? Here. Let me draw this. Any other questions can be asked. So let me just give that information also. So if you look at the magnitude of force, no, here it will be like that, the viscous drag. At different points, it will be acting different. That's why I'm assuming small element, then I'm finding out the torque in that one. Okay, so do this. Eta B omega T. Substituting limits and solving will get the required answer. Any other ideas they may bring? So and what should be the torque due to motor? Should be equal and opposite to this particular value. Torque due to motor should be equal to this one. If I apply a torque which is greater than the motor, then there'll be angular acceleration. In that case, what is V? V will become variable. V could R omega. Omega will become some alpha into time interval. I think things will be a little bit complicated. Try to analyze that also if you get a time. This a wiper is there. Next, you may bring some in rotation mechanics rod like a kept on a ground. Then it is given a angular velocity and released. After what time it will come to rest? The viscous drag will come. Here a oil layer will be there. After what time it will come to rest? Similar questions can be asked. Later we'll see that. When we complete mains exam, no, I'll bring some questions of this kind. Okay, let's take the next one. Okay, we have a cone. First, let me take the axis. I'll construct the diagram. You read the question. Okay, there's a cone. So surrounding this, there's everything is a liquid. Hope you are able to understand because I just share that the white color, there's a blue color is viscous liquid. This is the cone. Yellow color one is what cone? Okay, now I think you have better diagram in front of you. Very fast. The previous problem, what we had idea, no, the similar conditions will come here. So can we write directly a formula on the total cone? No, not possible, no. So better go for small element. Okay, I finished my diagram. Yeah, no. So this is that omega. Radius r. Theta also given information. This is a viscous liquid. And this is that cone. Typically less than 0.5 degrees settling. Calculate the torque needed to drive that cone. Why torque is needed? Because as you rotate, the viscous layer, the viscous liquid which is present here, it will exert a torque, no? It will exert a force. That force will set up a torque. So we should calculate the torque due to viscous layer, and I should apply equal and opposite torque so that angular velocity of the cone remains constant. I think this much is what the question that is being asked. What to do now? Where to begin the problem? We should assume it's a plane diagram. Try to assume this is a cone. Rotating cone. The cone has a large apex angle. I think if the 3D diagram, if you can assume, it'll be very easier. So here, let me take a strip. Let it be at a distance x. So you can see, look at that layer here. So here like this, if you assume it, you are going to get a disk, no, here. I'll try. This is the radius of the disk. The structure will be okay. I think I'm okay. This will be dr. This will be dr. You can write it. There's a point. Okay, here will this is a y. This is r. Able to understand? So shall I call this a disk or it's a ring? Anybody? Will you encounter here a ring, or shall I assume a disk on a cone? Shall I assume a ring on a cone? The liquid will be in contact with the cone here, no? So therefore, actually what it is, this is a ring on the cone. Where the liquid will be contact only in this shaded part here. Here the liquid will be in contact in this one. Like this, what I'm assumed a ring of radius 6. at a distance y, and this will be slant length r. I think more than this, I don't have explanation. After this, you should have that basic observation here. So here where the liquid is in contact here. Liquid is in contact in this region. I think, okay, if you can make this much here. What is the mathematics? Will go for it. Cos theta. Yes, given that apex angle, large apex angle, and the angle, the cone has a large apex angle and the angle theta shown. I think theta is not apex angle. Theta will be large, since apex angle is large, theta will be very small. So cos theta equal to x by r. So dr is also will be there. So let me differentiate this. Dr is equal to, theta is a fixed, no? So dr is equal to dx by cos theta. I want this area of this element. Anybody? Because in the viscous force, I need the area of contact, no? What is the circumference length? What is the perimeter of this? 2 pi x. And there's a width, no? dr. If it were vertical, I would have wrote that one. So since it's a inclined one, so therefore uh, the dA will be 2 pi x into dr. Okay, the dr is what I'm going to replace from this equation. In exams, I think you should really you should understand the diagram. That's what I feel. Okay, dA, we got it. What is the velocity at that particular point? Should be equal to x omega. Okay, let's write the force acting on the ring. So I'll write it. Elemental ring. Okay, force, viscous, drag. On elemental ring. dF is equal to, what shall I write? Quotient of viscosity eta. What is area of that elemental ring? dA. What is dA? Area of elemental ring. What is the speed of that? V. Omega. Let me show that tangential speed. V like this. I think better. Yeah. So what is V is equal to? V equal to x omega. I'll write it. What about the thickness? Because velocity gradient will write it. So shall I write divided by R or divided by Y? Because in the viscosity formula, eta A dV by dx will get, no? So that dr something will write. So shall we write this is Y? Velocity will be V. And what is this from the reference layer? It will be Y, no? This is the most difficult part of the question. Once you get this rational mathematics here, now you can say I'll substitute. This will be eta dA will be 2 pi x dx cos theta. V is x omega, and this is Y. We don't know why. Y should be eliminated. Y shall I bring in terms of x? Tan theta. Y by x. So Y equal to x tan theta. Eta 2 pi x dx cos theta x omega. Y I'll write it as x tan theta. So 2 pi eta. What all will get eliminated? Omega. Cos theta into tan theta will be sin theta x dx. This is the force viscous drag on elemental ring. So will there be any torque? Yes, there'll be torque. So let's go for torque. Torque equal to dF into, what shall I write torque? R into df, R into df, or x into df. Let me show that. I think I'll bring it here. This will be V. This will be df, no? And this is omega. Okay, fine. So what is df? Df will become x into df will be the torque. I think I'm in better position, or you convert into plane diagram. Velocity, this will be df. So what is the torque? Torque should be df into x, not df into r. So 2 pi eta omega sine theta. What shall be the limit? Torque about axis O, 0 to capital R. 2 pi eta omega sine theta r square by 2. Get cancelled. So pi eta omega r square by theta very small. We can put it. Theta, it should be in radian, not in degrees. Okay, there's a torque. What happened? That should be applied on the cone to rotate it with constant angular velocity in this one. So different types of structures will come, like disc, cylinder, cone will be rotated. So that torque we have to apply. What we calculate is torque due to viscous layer equal and opposite to that, the external torque should be applied. Okay, then this is like a torque due to R cube by 3 will come. Okay, fine. Yeah, R cube by 3. So 2 pi. Okay, I made correction. Can be asked. I think you check the EDO notes. So there are some set of questions of like this also there. So possibility of asking advanced. No? Let's come for a few more questions on viscosity. Please read question. Where the person's hand is here. Okay, I think no, get in because I. Okay, read question. I'll just draw the diagram. This one. Yeah. Okay, this is the person's hand. So with his fingers, what happened? He'll be pressing it. Okay, live. I think I'm unable to. Yeah. Okay, no, this is the, you will just, I think it was when you are throwing paper in dustbin, what you do? You just squeeze it and you are going to throw it, no? That's what the person, yes, go, you will do with the paper. So there are 3 sheets are there. So what you'll do is like 2 sheets, and it will not make it like a some ball. You just squeeze it so that it will become a conical shape. So something is telling pseudo conical shape. These is 2 objects of same shape but of different masses. What is the mass of this? Let it be 2m. Here m. So I think that's what, and here air is present. Surrounding is air. Okay, get into now get into the problem here. Okay, this v to power of x. No, please, I think this may not be visible. If you can, this is v to the power of x. That value of x we have to find out. It is like this. Huh? If the force of a resistance is proportional to v to power of x, where v is velocity and x is the constant exponent, what should be the value of exponent x? The viscous drag, what will happen to viscous drag? It depends upon the area of contact, like we have seen earlier problem. So what shall I do here now? Yes, definitely. So as they're in air, so what are the forces that are acting? The weight 2 mg. The weight of this is mg. Then after that, okay, let the velocity of this be v1, velocity of this be v2. I'll explain because I can't draw again diagram. I'm taking help of this one. So here, now what is the force that will be acting here? Viscous drag F1, and the force here will be F2. So what can be F1? Is telling it's proportional to alpha, this one. So here, I'll make it a small. For our understanding purpose. So this is 2 mg. The viscous force that is acting here will be, it's having speed v1, it is having a speed v2. So there should be proportional to alpha v1x, v1 to the power of x. So here this viscous drag will be alpha v2 power of x. He has given some information, the root 2 times. So in a given time, initially I too thought something big, but the question is asked in a very simplified way. Try to, you need not to draw so many diagrams also. Just for explanation purpose, I had to take help of all this one. If telling after the 2 objects acquire their terminal velocities, the heavier one mass moves root 2 times farther than the lighter one in a particular time interval. So let's do one thing. This is some time interval t1, here t2. In this time interval, or delta t, in this time interval delta t, it will move how much of distance? Say root 2x. How much it will move? It will move x. T equal to, I think I should not write t equal to 0. It is some, yeah, time interval. I'll be giving wrong information because it will acquire terminal velocity not immediately, after some time. Okay, fine. So this is what we have in a given interval of time. This will cover more distance. The heavier one will cover more distance than the lighter one. No. So do we have information regarding the speeds? So what is V2? I can write it as V2 equal to x by delta t. And what is V1 is equal to root 2 x by delta t. Any relation between V1 and V2? X by delta t, I'll write V1. Substituting this here. Okay, now let's come for, I'll square it. Let me, shall I square it? Now why I should square? Because, okay, first we'll do one thing. Okay, till here the relation between, okay, this is V1, this is V2. And both are moving with the same terminal speed. So any relation between them, can we bring it here? So look at the first diagram, second diagram. F2 alpha V2x is equal to mg, and F equal to alpha V1x equal to 2mg. And they're constant. So let me equate those two here. So F1 is equal to 2mg. F2 is equal to mg. So therefore, F1 equal to 2F2. What is F1? Alpha V1 to the power of x equal to 2 alpha V2 power of x. So V1x equal to 2. So let me square it. Will I end up any equation? So comparing equation 1 and 2, what we can say x now. Okay. There's no any big idea. So just we have to fight with the data given. Can be asked advance. There's no need of any very big thinking. So what actually we'll try to do, we'll try to think about how the viscous force is acting. How do I can calculate? Himself, he has given data, the viscous drag proportional to. You need not to bother. What is that alpha, sir? How all? Let's not bother. He has said shape to be same. No? So I think just be alert the data what they're given. I'll scroll down. Let's get into some problems on surface tension. Okay, this is the particular sphere when you remove that particular part. Not appearing. Okay, I'll get the diagram. Yeah. Yeah. Okay, this is the remote part. Okay, some rough diagram. Okay, we have like this. So I'm going to remove the any other concepts can be asked based on this. So if I remove this part, I think that this was the sphere will appear, no? So how the force due to surface tension. Okay, we'll have this. Huh? Yeah, no. It's a bubble, no? Spherical bubble. Two layers will be there. I'm unable to show two layers. Okay, this is AB. How the force due to surface tension will be? Means the above layer, this layer, how do it exert force in this direction, no? The basic idea. And this layer will exert force on this layer in this direction. So the force by this removed part here, or say, shall I call spherical cap, upper spherical cap, lower spherical cap. Force by the upper spherical cap. About imagine, nice, well and good. No need to fight all this. That is straight away we can manage. Lower spherical cap. So upper spherical cap in what direction it like that force? So it like that force tangentially. It'll be like this. Similarly, here it like that force in this direction. On the lower spherical cap will exert force tangentially. Some other color. Yeah, let it be. Okay, this angle is what we have. How much it is? Say theta 1. This is theta 2. This R. This R. So call this radius as R1. This R2. If this is theta 2, so this should be theta 2. This should be theta 1. Now you are going to have a circle here. Everywhere the force will be acting here. No? So similarly, show an arrow here. Now, nice. Student has to fight with the imagination here. He should start with the imagination. I think the surface tension do need this different types of the diagrams assumption. A student must develop. See, finding very difficult. I think now watermelons are available. Take watermelon, cut it here, cut at this part and this part so that this angle will be different, and try to see that. Then you keep that knife here, how that knife will act everywhere. Everywhere will act in this direction, no? Will be tangential. That's what the force due to surface tension. So this force you call F1, this as F2. Okay, net force on the remaining part. Okay, this is the remaining part. There's no other way you have to think. There's no other way you have to think. I think all of you now, what is your age? I think around 18, no? I think slowly now you do get attracted to opposite sex. There's a natural phenomena. I think you do imagination. It's quite natural. Even when I was 18 also, used to dream about girls. Nothing wrong. There's a quite natural phenomena. Okay, you do imagination, no? Like that. Do imagine here also. Simple. Do imagination. You'll be in better position. See, nothing wrong. Say how we imagine a girl, or a girl will imagine boy. That one, like I do like sweets more, so I do imagine. So like that also you do imagine these objects finish, or your science will be very, very easy. It will become. So what all you do imagination of general things like this, you do imagine, it'll be in better position. Okay, I think, okay, let's get into problem. Net force is asking. So first force on the force on the section AB. FAB will calculate. So this should be 2 pi R1. I'll write down the equation. Try to see 2 pi R1 into surface tension S into sine theta 1. Agreed? Why 2? Because two surfaces. Why this number 2? Two surfaces. Similarly, force on the section CD. How do these two forces will be acting? You take vertical components, or vertical components, horizontal component will cancel out, only vertical, the difference of this F net equal to FAB minus FCD. What is R1? We don't know R1. Okay, look at the triangle sine theta 1. We should imagine, this is very important for competitive exams. Every time you can't draw a diagram, I don't think so you'll be in a position in exam to draw this diagram. The imagination is what will help you to get a better rank. That's why I took several examples. When you can imagine so many things, why can't you imagine such simple ideas, geometrical figures, geometrical diagrams? What's wrong? So don't say, sir, imagine very difficult. When you can imagine so many things very easily, why can't you can also imagine this? So don't take it in another way, because I have to be on practical things, since what all we do practically, the imagination, the similar thing is what we can do it here also. Anybody? I think you have to work out a lot of maths. I think this will be 4 pi r square, 4 pi r. Yeah, I'll take out everything. 4 pi r is somebody mute it. Somebody mute it. Okay, no, you see this in say if he has given some values, okay, theta 1, theta 2. In exam, definitely I'll not give theta 1, theta 2. Suddenly, when you look at the options, you'll get scared. I think from where this R1 you replace R sine theta 1, how to replace R sine theta 2. Okay, no, sine square theta will come. Okay, I think the answer will be 28 pi RS by 25.
Sir, F net will be FAB plus FCD, no, sir.
Why you want to add?
Force is acting on opposite side, so it is like open.
You only decide. Net force is asking. What do you mean by net force?
It will elongate, no, sir. Like elongating force will be on both sides, F1 and F2 are opposite sides.
Okay, I don't know why you are thinking like this. First of all, he's asking net force. Tell me, what shall I write? I think have you just now read any elasticity problem? Nothing, no, nothing to do here. So it is just like net force acting. So I should take the difference of that. Why F1 plus F2? It should be difference of forces, no? Net force I'm asking. Okay.
FCD is in opposite direction, no, sir. So FAB minus FCD means FAB plus only.
Okay, I know only this much. Tell me like what is the net force? What you write? Difference, no? I don't know what logic you are applying. No, what is the force? You'll add up.
Okay, sir.
Hmm? I think you got confused with the elasticity idea, that one formula I gave that you want to apply. I'm not discussing here. If I ask you elongation or something, okay, think in that way. Nothing wrong. I think you are studying now elasticity and you want to bring elasticity here. If I ask you something elongation or something strain, no, okay, then take help of that formula. But here is asking net force. I should take difference. Let's go for next one. This is a very, you can say almost in very good problem with sufficient viscosity. I think already I discussed. I can't remember, but possibility of asking such things in advanced exam. Very sure. The professors do like to ask such questions. Yeah, read it. He has not given diagram. A bubble of radius are made up of soap solution. Okay, there's a bubble. First, let me put tube. Please do revise such small ideas. Huh? Very important. Huh? Okay, there's a bubble. Okay, there's having a radius r. Okay, I'll show two surface. At least you'll come to know why I'm writing the equation like this. Huh? Okay, there's a bubble. There's a layer. Soap solution is present only here. Huh? It's not a drop. Inside everything, there'll be air. Okay, this is what initially t equal to 0. And this was that tube. T equal to 0. Okay, this is soap film. Soap bubble, I'll write it. Outside also, it'll be present. So first, directly get into what is the pressure. Outside atmospheric pressure is P naught. Surface tension, anything? Okay, not there. Okay, we'll write it. P equal to P naught plus St into capital R. Now, with the time, what will happen is the pressure is more inside the bubble than outside. No, so therefore now the air what happens starts rushing it here, or you can compare your pressure here P naught. Here air will be present P naught, or even the air what happen will also be here. So will be P naught here P. So the air starts flowing no from higher pressure to lower pressure. So as the air starts flowing, what happens to bubble? The bubble starts collapsing. So that's what he's asking. Estimate the time interval taken by another bubble of radius. Okay, I think okay. If the closed end is open, when I close it, no, okay, it will be there that one. So when if the closed end is open, the bubble collapses in a time interval delta T naught. So how much of time the bubble will take to collapse? Delta T naught means the air what pen will escape. So as it escapes what pen, the bubble what pen will take shape like this. Then and finally it will be. So one more small diagram. If you can understand the sequence, it'll be easy for you. So it will be initially like this. After some time, and after some time will be like this. Will keep on collapse as it does like this. So the air water pen will rush here. The air will rush here. Let area of cross section of this, let it be A. The bubble, okay, that particular thing. So what is the size of the bubble? The radius of the bubble keeps on decreases. I think I can help you diagram only this one. More than this, not possible for me. So what is the pressure here? P naught. The pressure here, let it be P. Area of cross section of this, let it be A. moving air. Fine. Okay, now what to do now? That time is asking how to bring that time. So what's happened to volume of bubble? Volume of the air inside the bubble. Volume of the bubble will decrease, no? So let the radius be r. So let's get into the mathematics. Volume of the bubble equal to 4 by 3 pi r cube. So what all amount of air that is decreasing in the bubble, that particular air will rush through the opponent. The moving air, I'm putting this one. So the amount of air decreasing in the bubble should be equal to amount of air that is coming from opponent per second. So shall we use conservation of mass principle? So here, rate or the amount of air decreasing in bubble is equal to per second is equal to amount of air rushing through open end per second. So this should be equal to rho into change in volume dV by dt. Okay, this I think there are. So shall I use U here because we will be using for volume. So dV by dt is the volume here, rate of change of volume, density into rate of change of volume. What shall I write here? Rho into flow rate. Flow rate, density into flow rate will be the rate of mass, no? It should be. So area of cross section into U. So we have equation. So I'll differentiate this dV by dt. So this will be 4 by 3 pi 3 r square dr by dt. What will happen to radius? In fact, it decreases. So shall I go for negative sign? Why negative sign? Radius of bubble decreases. Okay, no. So let me substitute here dV by dt. Rho get eliminated. So this will be 4 by 3 pi 3 r square minus dr by dt a into u. Okay, somehow I have brought equation. Let's apply Bernoulli's theorem between these two, inside the bubble and at the open end. Okay, applying Bernoulli's theorem. In the bubble and between bubble, in the bubble line between, I should write, no? Applying Bernoulli's theorem between between points, okay, points inside the bubble between the point inside the bubble and open end. Okay, what is the Bernoulli's theorem? What is the pressure there? P. What is the so the air starts rushing here. So what we can take this one? This will be a test. So P is equal to outside pressure there, P naught plus rho U square. Okay, substitute. I think let me give all the number 1, 2, 3. Substitute, put 1 in 3. Let me keep it here. This is. So okay, the initial background is what? We have made it. Okay, now I'll come for this one. From 193, so P naught plus 4 ST by R is equal to rho u square by 2. So with this, I'm getting expression for speed of the air. So this will be 8 st by rho r. Call this equation any number. Okay, still our question is what, like time taken, no? How to bring that time taken for. I think the dt is available here. You can see the equation 2. This is what I'll put. Now 4 into I'll substitute because dt is available. So I got expression for this. So 4 by 3 pi 3r square a into this will be u will be 8 st by rho r. Okay, I think 1 3 we can eliminate it. So what all we get? R to the power of 5 by 2. R to the power of 5 by 2 dr equal to minus a by 4 pi initially r, finally 0. This is time. Anybody just solve it and give the final answer, delta t naught. Okay, the dt is what? That we have taken earlier. R to the power of 5, no? So this will be, I think, 4 pi. We wanted t, no? Okay, let it be. I'll write down the 4 pi a will come. 4 pi a rho 8 st. What are other things? R to the power of 7 by 2 by 7 by 2. Can we write it? Final expression 8 pi anybody final equation? Okay, this 2 will be there, no? Just simplify, give me final answer one. 4 will come. 4 pi a rho 2 st. 7 will be there here. 7a r to power of 7 by 2. Okay, check it.
It will be 2 pi, sir.
2 pi, no, one from here 1 2 will come, no? 8 st. Root 8 is there, no? So root 8, I'll take 1 4 outside.
Okay, sir.
Huh? Yeah, that one. Okay, now you compare when the radius becomes r to eta r, then it's asking what can be the relationship. Okay, there's a one problem, you very important. The bubble will not collapse. It will collapse gradually. It will, in fact, it will take some time.